But as it stands, what I've done is I've looked at fibre content as a marker of carbohydrate-containing foods. And to do that, we'll focus on fibre, and we'll focus on fibre in relation to human intervention trials and observation studies as related to diabetes and total fibre content, fibres obtained from food groups, and their synthetic or extracted fibres. I'm presenting this work on behalf of Professor Jim Mann and Dr. Lisa Temarenga and myself. Professor Jim Mann was meant to be here, but he has a scheduling conflict. I work for Jim at the University of Otago, researching glycemic control with a component of my thesis on the structural integrity of dietary fibre. And my other supervisor, Dr. Bernard Venn, is in the audience today. Although this conference has received industry funding, my participation here is not, so we aren't receiving any support for presenting here today. And none of us make any money from promoting fibre content. Let's get into it. So there are multiple definitions of what can be considered dietary fibre. The most influential early definition from 1976 states that dietary fibre is the residue derived from plant cell walls that is resistant to hydrolysis by human alimentary enzymes. This definition stood for around 20 years. However, with changes in food production, processing, and technology, a more detailed definition of dietary fibre was required. On the slide is an abbreviated version of the Codex Alimentarius definition, which was accepted in 2009 after more than 16 years of debate. The dot points are particularly important, where the first dot relates to fibre in food, the second and third dots allow for extracted or synthetic fibres. This Codex definition includes the non-specific term competent authorities and generally accepted scientific evidence, which dilutes specificity and allows for something to potentially be considered a fibre in Canada, but not in the EU, for example. So when considering dietary fibre as a marker of carbohydrate quality, we have no widely accepted definition and definitions that allow for inter-country variation on what is fibre and what is not fibre. The definition is important, but equally is the method to assess the fibre content of the food we eat. Prosky in 1988 described an enzymic gravimetric method, which has since been used widely to determine fibre content of foods. This Prosky method captures non-starch polysaccharides. The resistant starch is not degraded in the small intestine, and some inulin. The Inglis method is an enzymic chemical method used predominantly in the UK up until around 1999, and only assesses the non-starch polysaccharides. So although very few studies use the Inglis method nowadays, it is important to note that the Inglis method captures smaller fibre values for foods, making comparisons of epidemiological data between studies, countries, and over time frames difficult. Now, this third method I've placed on the slide and another publication by the same group from 2012 I've put up to show you that there are ways of capturing all potential components of a definition of dietary fibre. And it is important to note that the best practice methodology of fibre content assessment changes over time, which introduces doubt when comparing fibre content over a time course. So here are some foods containing important quantities of naturally occurring dietary fibre. These are the foods commonly captured in our food databases, and these are the foods nutritionists and dietitians traditionally discuss when recommending high fibre intakes. As for a primary source of fibre, there isn't always one. Is anyone brave enough to call out a major source of dietary fibre in the United States diet? I heard someone whisper chips. Can you say it louder? So potatoes, they're not high in fibre, right? But I see your point. They're eaten in large amounts. Anyone else? Coleslaw? Popcorn. Sushi? Yes, good. Rice? Very good. So for NHANES data on United States adults from the 2003 to 2006 24-hour recalls, they identified yeast bread and rolls as the top contributor of fibre, but it attributes just over 11% of total fibre intake. Fruit, legumes, and indeed the potato round out the top 4 fibre sources and contribute only 35% of total fibre intake. So it's quite a wide variety of foods that they get their fibre from, and they're not getting it in very large amounts. So with no considerable sources of fibre in a dominant Western diet, how much is being consumed? The top graph is NHANES data from over 23,000 24-hour dietary recalls, looking at dietary fibre consumption in the US population over a 10-year period. I've cherry-picked the numbers from an AJCN paper. That's just under 17 grams per day, although over the time frame it does appear to be increasing. It's very difficult to be certain that this is an actual increase in the amount consumed, given that changes in methods of fibre assessment over time. This could be confounded by changes in AOAC methodology. Looking across the North Atlantic now, the column graph contains EPIC data from a Bingham paper. Fibre intake per day varies between countries in Europe, from 20 grams in the UK to just over 25 grams in Spain. I don't know if you can see them, but it's France, Spain, UK, Netherlands, Germany, and Sweden. So the recommended levels for dietary fibre intake for the general population are generally 25 to 40 grams of dietary fibre per day. So these amounts being consumed are below population recommendations. European Association for the Study of Diabetes recommendations are for individuals and is ideally greater than 40 grams per day, with vegetables, fruit, legumes, and whole grain sources, cereals the preferred sources. So for connections between dietary fibre intake and diabetes, for an observational study, here was a slide from yesterday. It's a Frank Hugh published a review of prospective cohorts as a meta-analysis, examining various nutrient determinants of type 2 diabetes. Diets high in cereal fibre are associated with lower risk of diabetes, just one here. And vegetable and fruit fibres did not appear to influence diabetes when looking at prospective cohorts. Not shown here is legume fibre, which showed similar non-associations with diabetes risk in the Nurses' Health Study as the fruit and vegetable fibre sources do here. And possible reasons for this is that the non-associations is that there is a little difference in fruit, vegetable, and legume fibre consumption between the low and high consumers in a general population. And this is still a very viable area of research. There was a prospective cohort study published just 2 weeks ago in Diabetologia in 30,000 Europeans with similar findings as presented on the slide here for fibre content. Considering intervention studies, this is one of the first randomized controlled trials on a high-fibre diet in glycemic control. 14 type 2 patients spent 6 weeks on a 60% total energy carbohydrate diet, high in cereal fibre and tuberous vegetables, versus the recommended diet of the time, which was 40% carbohydrate. This 24-hour glucose... Is it on? It's on. Good. This 24-hour glucose profile displays an attenuated glucose response after 6 weeks on the high cereal fibre diet, high tuberous vegetable. Over the 6-week time frame, HbA1c also reduced. This is a study on fibre from cereal and root vegetables, so it was important to note that they generated a difference in carbohydrate load as a percentage of total energy between the intervention arm and the control. It was not solely a difference in fibre content. If you look at interventions that did just move fibre content and not the total carbohydrate load as well, we see a similar response. And someone made a really interesting comment yesterday. We all present on control diets against an intervention diet with less carbohydrate. This study bucks that trend, and it actually went up in carbohydrate for the intervention. Okay, this is a Chandalia publication. It's a crossover study of 13 participants with type 2 diabetes, and they went on another 6-week diet. The control was the diet recommended by the ADA at the time as suitable for people with type 2 diabetes. The intervention diet was matched for macronutrients, except for instead of 24 grams of fibre per day, it was 50 grams of fibre per day. And high fibre fruits, as well as oatmeal, were used to generate the set difference. As you can see from the sample diet, there's papaya, orange sections, and fresh peaches. And again, a 24-hour glucose profile. You can see that the high-fibre diet generated a reduced glucose response when compared to the ADA recommended diet, and they did not alter the carbohydrate as a percentage of total energy. This difference was generated solely by fibre. This is a third intervention study using fibre from foods. It's different from the others as it was undertaken in a type 1 population. Rosobo-Giacco et al. Generated a 35-gram difference per day in fibre between diets. The low fibre was 15 grams, and the high fibre was 50 grams per day, with an emphasis again on high fibre fruit, vegetables, and legumes. This was a 6-month trial with intention to treat and an analysis considering dietary compliance. In ITT analysis, mean daily blood glucose concentration and the number of hypoglycemic events favoured the high fibre diet. When considering compliance, the improvements in blood glucose and reduced hypoglycemic events strengthened, and the high fibre diet observed a significant HbA1c reduction as well. So these three interventions I've just shown all show an improved glucose response with diets higher in fibre than a control. These are just examples, one of the very first, one from the USA and one from Europe. There are many other interventions altering fibre content undertaken in populations all over the globe, and considering the totality of evidence, they show similar findings supporting fibres from foods and diabetes risk reduction and improved glycemic control. I want to make a separate point with this study on the role of the food structure in physiological effects of fibre in our bodies. This was written up as a GI paper on 20 participants with type 2 diabetes. And what they did was they used the same foods in the diet, the same macronutrient profile, and the same fibre content, but one diet used the complete cereals and legumes, and the other one ground down the cereals and legumes. And this is what's driving the change in the 24-hour glucose profile on slide. So the food structure is very important here on the effect of fibre in blood glucose control, with processed or added fibres, those not incorporated in the structure of the food, showing a diminished physiological effect. This is a key point and one JBM mentioned with her slide, showing the oats and an altered physiological effect due to the state of their processing from whole to processed. So far we've been talking about fibre in foods, but fibre from whole foods is not the full picture. We need to consider the emerging use of what has been termed functional fibres. I don't agree with the term functional fibre, as it implies a usefulness that doesn't require substantiation. So I would say that in the food supply of today, there is a whole range of extracted and synthetic fibres that have been added to food in processing. The term extracted relates to fibre taken from one source and added to another. An example of this is inulin. Or the term synthetic relates to fibres created and then added to food. Taking a look at some of these extracted fibres, you can see that intervention trials have considered their effect for quite a while now. In an early classical set of studies by Jenkins, lower urinary glucose excretion was observed in 9 type 2 diabetes patients on 25 grams of guar gum per day. Guar gum is a fibre extracted from the guar bean. It's a plant native to Asia and Africa. Jenkins has undertaken similar work to show lipid improvements from guar gum and has favorably compared guar gum with pectin and wheat fibre in dietary interventions. You all right? Sorry, get some water. Further research was undertaken on guar gum in the 1980s. This work was by Antti Aro. It is a 3-month intervention with 21 grams of guar gum or placebo per day for 9 participants, and again with type 2 diabetes. After that 3 months, you can see considerable differences for postprandial blood glucose response, and it's not driven by an altered insulin response. The top one there is the blood glucose. As with Jenkins, Aro also considered CVD risk and observed significantly lower total cholesterol and LDL cholesterol with a 15 gram of guar gum per day controlled trial. I've decided to present on guar gum today as an example of extracted fibres, but it's just one of many. Inulin, chitin and chitosan, and xanthan gum. Other examples of fibres extracted from one source and added to processed foods. There are many intervention studies on these extracted or synthetic fibres showing their physiological benefit in glycemic control. However, when you add a fibre to a food, it doesn't remove the presence of the other nutrients in that processed food. And this is our last key point for the talk. Extracted fibres are added to a range of different products. Processed products that may contain various levels of other nutrients such as saturated fat, added sugars and simple carbohydrates, sodium or excess calories. This yogurt, for instance, is low in added sugar. And they've boosted the fibre content remarkably. It's up to 20% of the daily value. There's negligible sodium and saturated fat. From the perspective of adding nutrients that we try to minimize, they've done a really great job. For these cookies, one cookie has 10 grams of added sugar and 2.5 grams of saturated fat. I'm aware that you could have no chance of seeing these from the back of the room, so I apologize for that. Once again, the fibre content looks really good in these products with the dietary fibre 5 grams per one cookie, giving 20% of the recommended dietary intake. And Eggo Waffles Fibre Plus Antioxidant Chocolate Flavour. I haven't had the chance to try these yet, but if you know where to get them, I'm on the lookout for them. The yogurt and the cookies were snack foods. These, I guess, could be considered an actual meal, so maybe the level of saturated fat, sodium, and added sugars are acceptable for you in that context. But I've put these 3 products up to show variation in the nutrients that go with the added fiber in the processed foods. So, considering the points I've raised today, here are our conclusions. Dietary fiber in the past predominantly came from food, and there is an enormous amount of evidence that is protective against diabetes and non-communicable diseases, with no evidence to suggest a negative effect in the population. So dietary fiber has traditionally been a useful marker of carbohydrate quality. However, the current Codex definition includes extracted and synthetic fibres, and we do not have the long-term evidence to support their use. This definition, the increasing use of fibres added to food, and the variable nutrient levels of processed foods promoted as high fiber muddy the use of dietary fiber as a marker of carbohydrate quality. Fibres added to processed food do not negate added sugars, saturated fats, or sodium, the co-travelers that Professor Brenmiller referred to in her talk. Therefore, knowledge of the source of dietary fiber, the degree of processing undertaken, the nutrient composition of the carbohydrate-containing food determine the extent to which fiber may be considered a valid marker of carbohydrate quality. Thank you very much.